week's module, we talked about the gradient echo pulse sequence, and in addition to that, we talked about the k-space and how k-space is traversed via a gradient echo pulse sequence. So what I'd like to do here in this video is to show you, is to step through an animation that may help you see how excuse me, how k-space is traversed as the pulse sequence is executed. So what we have here, of course, is an RF pulse in the top line. This is the time axis. Gradient Z, this is the slice select gradient. And we have the phasing of gradient here. GXR is the read gradient. And ADC here stands for analog to digital converter. So what I'm going to do here in the animation is step through here to this point in time. So what we've done at this point in time, the RF pulse has been turned on at the same time. The Z gradient has been turned on in order to do slice selection. And we have a positive going lobe, and this negative going lobe, remember here, is to rephase the spins that have been dephased, okay, to balance that out, the gradient out. But the main focus again here is on what's happening in k-space. So you see at this point in time, we're at the 0 k-space, kx0, ky0. Now, as I step through this, the first gradient that I'm going to apply here is the largest value of the negative going lobe of the phase encode gradient. And what you see here is this red arrow is indicating that by that large phase encode gradient, we've gone from 0 in k-space to kx0, ky min. Okay, now as time progresses here, you can see now as time goes on, the phase encode gradient returns to 0, but the read gradient now has been turned on. Negative going lobe, so we're going to move to this direction in k-space. Again, as we proceed here in time now, at this time here, we were going positive in the read gradient. And at the same time that we're going positive in the read gradient, the analog to digital converter is being turned on. So this is the first point we're going to sample. So while the read gradient is on, we're sampling data, and we're traversing k-space. So here you can see this arrow corresponds to this position in k-space roughly. Okay, again, this is just really for animation purpose, but just to give you an idea of what's happening here. So as I proceed, as the read gradient proceeds, is kept on, we're traversing k-space here. We're sampling the data here. Okay, so I'll continue that. And then at the end here, we go off, and then we start. This is the end here of 1 repetition time, or 1 TR time. So the next TR time, we come back to this point. So again, we apply an RF pulse, Z gradient, and now we're at this point in time again, and we're going to apply the next phase encode step. And this time the phase encode gradient isn't quite as strong. You see it's only here, and that brings us from 0. So let me back up here one step. So we're back here again, and so we're back at 0 k-space. Okay. So now we apply a negative going phase encode, but we're slightly different, right? Because we just applied this larger one before. Now we're applying this slightly less larger phase encode gradient, which is going to move us to this position approximately in k-space. So we're not going all the way down to k-min, but we're going here instead. The next step, we apply the read gradient again. This is the same amplitude, which brings us to this position, to kx min. And similarly, I'm not going to show all the steps here. As the read gradient is turned on, we sample these points Okay, as we go this way, we sample these points in k-space. And then the cycle continues. We go around, do the next phase encode gradient step, brings us to this point in k-space. We turn on the read gradient, happens to be a negative going lobe again. Move to this point in k-space, kx min, and then turn on the positive going read gradient, which moves us this direction in k-space. Okay, and so on. Here, and then we read smaller value of phase encode gradient, smaller movement in k-space, and then read gradient brings us over there again, and then we read the data. Continue again, here, do it again, do it again. Keep the mouse out of the way. Notice now, so for this one we have no phase encode gradient at this step, that we don't move. So so now I've just skipped over, and now I'm just showing you a bunch of steps here at once, just to make this a little bit shorter for you. Okay, and then finally this is our last step. So here, this is the largest value of the phase encode gradient, brought us to here. And again, we're using the same read. We come to this point, kx min, ky max, and then we read the data points there in the last line of k-space. Okay, so if you have questions, please let me know on the discussion forums, and I hope this was clear for you. Thank you.